Hey Adam, what's 2/3 the size of 4090, 25% more expensive, and a whole lot faster?
What?
It's the RTX 5090 Founders Edition that's on the table in front of us right now.
Oh, we should talk about it in this video.
I think that's a good idea, and we have benchmarks. We've spent a lot of time experientially testing, and we're going to tell you everything you need to know about the 5090 Founders Edition right after this.
Let's do it. This video is about the Nvidia GeForce RTX 5090 Founders Edition. The embargo is up. It's not quite available to purchase yet, but we're here to talk about it. Not only just talk about it from a benchmark perspective, which we do have the charts. If you want to go to those, just hit the little chapter marker, go forward. But we've talked extensively on the Full Nerd podcast about how it's a little weird right now to benchmark GPUs because there's a lot going on, right?
Well, because in the old days, you just benchmarked the video card. It gave you a bunch of numbers, and those numbers meant the same thing for every video card that you tested, more or less. And you would say, okay, the bigger bar's better, and you move on. That's it.
Yeah.
It's just like we always say here, always be testing.
Always be testing.
And bigger bar's better.
And bigger bar better.
Yeah.
But yeah, it's not just the case. There's a lot of stuff other than just the hardware. We do have some benchmarks for raster and ray tracing, upscaling, all that kind of stuff. But I kind of want to start the conversation talking about some of the experiential stuff because we've had it in our hands for a week. We've done it, we've tested it in different ways and just played games on it just like a normal person would. So I think part of this is to talk about the actual, this hardware, the Founders Edition hardware. Part of it is to talk about the actual upscaling technology. DLSS 4 is new, but then actually get into the benchmarking of the 5090 specifically is going to be a little bit later. So let's start off with the hardware. So first up, let's talk about the Founders Edition card here of the RTX 5090. This was provided by Nvidia for this review embargo. We did get it in. We've had it for about a week, and it is a truly amazing piece of hardware. I've been surprised by it. How about you?
I was really blown away. I was expecting, they're following up one of the all-timers with the 4090, right? It's expensive, It's big, it's incredibly fast. How do you beat that the second go around? Well, you make it faster and smaller, and it turns out it's a lot smaller. It's the same length, but you can see 3 slots, 2 slots.
Well, and I really feel like everyone expected the 5090 to come out and be like a 4-slot card, right? And so for Nvidia to come on stage and be like, well, actually the 5090, boom, 2-slot, is truly remarkable. And you're right, in almost every dimension, it is the same length, width, but the actual thinness here is like, it makes a huge difference. It is not just 2-slot, it is a true 2-slot card.
And the secret is that they redesigned the board so that it's double pass-through. There's holes that go straight through. The air on this bottom fan doesn't have to turn 90 degrees and exhaust out the back. It just blows into the top of the case. And the secret is that the board design is just in this center square of the thing. There's a daughter board for the PCI Express port, and there's a daughter board for the HDMI and DisplayPort ports on the side. But the rest of it's just here in the middle, and then it's cooler supporting the rest of the case.
Yeah, and I was worried about construction because you would think, oh, if you're moving the PCB to the middle, that you might introduce a little bit of flex to it. But I mean, I have bent this thing multiple times.
It seems pretty robust.
And yeah, like it does not feel like it's gonna snap in half. They made this very rigid and very solid. I do wonder like if we're gonna see any sort of similar layout from AIB partners though.
I do, and I also wonder what Modder's going to do this. I think there's a connector that comes off of the main board and goes to the PCI Express port. I don't know why you couldn't just bypass the riser card entirely and have that go straight to the port on the motherboard. Right. So there's all sorts of interesting opportunities here because of this board design.
Yeah. So, but with that redesign, I expected, okay, well, it's either going to be hotter or it's going to be louder, right? If you're
slower.
Or slower.
Yeah,
true. And so we did do some audio testing. I will say this is not scientific. We did not get out decibel meters and do anechoic chamber testing, though I am curious to see some of that. This is just kind of using it in 3 different scenarios actually. One on the open air test bench here, one in my small form factor gaming rig, and then you had one too.
I have a compact mid tower, the Fractal Meshify compact.
And so what do you think? How loud would you compare this to the 4090?
So the 4090 is a pretty quiet card. The previous generations have been quite loud under load, and I was blown away by the noise performance of the 4090. And this seems comparable, maybe a little bit louder when I did side by side with similar workloads.
Yeah, I will say the same thing for me applies on the open air test bench. It was obviously louder in the smaller form factor scenario, but that's because the fans were having to keep up a little bit more. But I did not feel like it was anything that different from a 4090 in normal use.
And so when I was doing my testing, I loaded up a scene in Indiana Jones, and I played it with the 4090, I played it with the 5090, and I got down on my hands and knees under the desk listening to from the outside of the case, and then I opened the case to see if I could detect a difference. You could hear that the 5090 was a little bit louder with the case door open, but with the case door closed or sitting at my desk 4 feet away from the case, I couldn't hear a difference.
Yeah, I will note on this sample that I had, I did notice coil whine when it was on the open air test bench sitting right next to me. But when it was under my TV in the small form factor gaming rig, I didn't notice it over there. Did you notice anything on yours?
So after you said this and I heard it yesterday in the office, I went home and laid down on the floor while it was at varying speeds, and I didn't hear any coil noise on the sample that I have. So 2 samples, one has coil noise, the other doesn't. Probably something to keep an eye on, but I'm not worried about it right now.
Yeah, for sure. Then on the flip side, if it's not louder, even though it's smaller, then maybe it's hotter. And actually, we did some more thermal testing. I'll say the benchmark. The one benchmark I ran for thermals was Call of Duty Black Ops does report a thermal temperature. I'm not exactly where on the die it is getting a temperature, but it is a like for like reading compared to the 4090. And I did see about a 5C increase over the 4090 in that one benchmark that I was running.
And I saw similar jumps from the 4090 to the 5090. Again, in Indiana Jones, I was seeing 57C on the Indiana Jones with the 4090, and it bumped up to about 63 on the reported by Nvidia in fan control or the control panel temperature.
Yeah, and that was about what the same it was on an open air test bench. I did just for fun, because like we say around here, always be testing.
Yeah,
right?
that's what we always say.
That's what we always say. I threw this in my small form factor gaming rig, which is a Fractal Terra. This is not the ideal situation to put it in because it is bringing cool air in from the side and then blowing all that hot air into the back of the motherboard, into the back of the power supply, and just sitting right in the case. Not a good scenario. And under the heaviest load that I could push on it, which was Indiana Jones, like fully path traced, all that kind of stuff.
4K, the whole deal.
Oh yeah. And it was about 84C, which is not good.
It's warm, but that's well within the operating envelope, and it's also like if you're looking at a 2080 or 1080 era card, that was pretty much the temperature that they ran at. So
yeah. So I once again, I don't recommend anyone does that, but I wanted to see it just for fun. I do think that is one downside of this design, is that a lot of sandwich style cases like this one are either going to have to figure out how to get a little riser out of there so that there's more air more area for the air to flow through, or something like that, because that's one downside of this card. In some ways, in that scenario, I wouldn't consider this a true 2-slot card because you kind of need that third slot for a little bit of gap for the air to pass.
I mean, the groove on the back isn't quite enough. Huh?
Yeah, not enough. But hey, still pretty good. The last thing to note, thermal-wise, is that we did get some temperature readings with a infrared.
Yeah, infrared pointing thermometer. It's not super reliable, but it's a good way to get a general feel for like what the hot and cold spots
like skin
are.
temperatures, right? Yeah. And where did we see the worst?
So the hottest spots were where the board is, unsurprisingly, in the middle of the card, and they weren't on the fan side; they were on the back side. So it was warm on these two kind of edges, the triangle pits. And then the hottest spot on the card was actually inside this V, which presumably is behind either the board or the vapor chamber, whichever side we're on, where it was about 134 Fahrenheit, which is warm. It's not hot enough to burn you, and it's definitely cooler than some of the 10 series cards I tested 6-7 years ago.
Yeah. The last note on the actual hardware itself is that the 12-volt 2x6 comes out at an angle here. I do like that. That definitely helped, especially in my small form factor Terra. But I kind of don't like that it covers up the light up logo. It's a little weird to do it that way.
So on mine in a mid tower that's horizontally mounted, the cable just drops straight down and I ran it out the bottom, so it doesn't cover it at all.
Oh, okay.
I like, so this is using essentially the Rev 2 of the 12 volt high power, the 12 volt 2x6. It's a slightly changed connector. There's some stuff about the design that changed, like they're color coding the tips so you can see if it's plugged in all the way. So hopefully you won't light your video card on fire. They provide a dongle for it, a 4-pin cable.
It is a nice dongle. It's
got
nice
braided
dongle.
cables. They're floppy. Yeah. They're not going to put a lot of pressure on the connector.
The connector has a lot more.
It's a beefy shroud.
Yeah.
Look, if you're buying a $2,000 video card, don't be a cheapskate. Go buy a new power supply.
Just get a new power supply.
Get one that has the right cable and move on. You need a 1,000-watt power supply anyway.
Yeah. Technically, you do. I will say in my small form factor rig here, I have an 850-watt power supply, but this is running with a 7800 X3D, and I only saw, the way I have it configured, it wasn't going past like 60 watts. So I didn't see any drops because of the smaller power supply. Technically, you should have a 1,000-watt, but I think, under the right scenario, 850 is doable.
It's also January, Adam, and it's cool. When you're in August, it starts getting warm. The efficiency's going to go down. The efficiency's going to go down. Your power supply is going to black screen your computer.
Probably. Well, and so that's it for the actual Founders Edition hardware itself. We do not have any AIB cards in right now to test it against, but we will be looking at that in the future. But for now, I would say, hey, this Founders design is nice.
The big outstanding question for me is, will a more traditional AIB board design pull more performance out of this hardware? And we're not going to know that until we have a chance to test those cards. So,
good question.
Yeah.
Okay, so that was the actual hardware. But for any of the RTX 5090s that come out, whether it's Founders or AIB partners, the 5090 brings with it, well, the whole 50 series brings with it a brand new version of DLSS, DLSS 4.
Yeah, so there's two things here. One is that DLSS used to mean making small renders bigger with AI, and now DLSS means a family of technologies, including the technology that makes small pictures bigger with AI, but also includes things like frame generation and reflex and ray reconstruction and a bunch of other stuff.
Yeah. So, we should talk a little bit about each one of those kind of things. We don't need to go too deep into all of them. There's already a lot of good talks, like the fine folks over at Digital Foundry kind of going into the nuts and bolts of it. But there's interesting things to talk around this. I think the biggest one being the thing that is exclusive to the 50 series, and that is multi-frame generation.
Yeah.
So the original frame generation was reading one frame and then kind of guessing with AI what the next frame was going to be, right?
Yeah, so they take the previous frame that was rendered, and then they take vector data and some other data that the game engine and the game handed off to the video card driver, and they'd use the motion of the camera or your controller or your mouse and render the next frame with that information in mind, right? Because usually you can tell, oh, it's going to be this, it's going to be off by X number of pixels shifted to the right, and you know what's going to happen.
Okay, well, and now with the 50 series, they've introduced multi-frame generation. So MFG is how I'm saying it for short, and that's taking one rendered frame and getting up to 4 times AI.
3 additional frames for 4 total frames.
Yeah, exactly.
And so those 3 frames are all generated at the same time, which is the interesting part. It takes the initial frame, it generates the next 3 frames, and you think, oh, this is for taking a 15 frame per second game and getting to 60 frames a second. That's actually not what we're talking about here. What we're talking about is getting a 60 frame per second game up to a really, really smooth 240 frames a second, so that you can take advantage of your really high refresh rate modern displays.
Yeah, and traditionally I have used the original frame gen, the non-multi-frame gen version in a handful of games. There's not a ton of them that are out, but I have tried to force myself to use it, and I have not liked it, but not because of the latency thing, which I think maybe you'll get into. But for me, it was usually an image quality thing. Like I'm somebody who likes to turn up all the bells and whistles, play at 4K, and sacrifice overall frame rates for the supreme image quality.
Smooth 40.
Yes, exactly. But the actual frame generation in the games that I was trying, it degraded the image just enough for me to be like, I'm not going to use it. I'm going to figure out another way to get performance back, whether it's upscaling or dropping some settings like that. So I wasn't a big fan. But where did you stand on the original frame gen?
So my rule is generally for competitive games, I go performance at all costs. But frame gen added enough latency that, especially on mouse and keyboard games, I didn't want to use it because it made the controls feel just floaty enough that it was disconcerting for me. On single player stuff that I'm playing with the controller mostly, games like Indiana Jones or Star Wars Outlaws that are graphically intense, have a lot of ray tracing and a lot of stuff to see, I would often flip frame generation on if I felt like the performance wasn't at the level that I wanted it to be. But I also am a non-standard person because I typically use a 1080p 360 hertz panel, which means that I'm probably going to be okay.
Yeah, you're probably going to be okay.
Probably going to be fine.
But you did try this new multi-frame generation.
Yeah.
How do you think it compares to original frame generation?
So the thing that I love about the multi-frame generation is I'm not particularly frame rate sensitive, but I'm very stutter sensitive. So when there's a large variance between the fastest frames and the slowest frames in terms of milliseconds for frame render, that really leaps out to me, and it can make a game that's running at an average frame rate of 150 or 200 frames a second feel like it's running at about 10 or 15 to me. And the multi-frame generation made Star Wars Outlaws, which has a lot of stutter if you played that game, feel smooth as butter. It felt like, I don't know, the best way I can think to describe this is if you ever played Doom 2016 or Doom Eternal, those games feel so smooth.
Oh, so good.
Even when they're not running, even they're only running like 90 frames a second, they just feel really smooth because their frame pacing is really spot on and the frames come at a really even gap between frames. And what the multi-frame generation does with Outlaws, especially at the 3x or 4x setting, is it makes that game feel like Doom Eternal, which it does not feel like on a 4090.
Yeah.
So shout outs to multi-frame gen. I went from being, I'm a little skeptical about this, to straight up believer. I'm still not going to turn on Call of Duty or Fortnite, but for single player stuff, I'm all in.
So I will say for frame gen, this applies to multi-frame gen and the original version of frame gen. I'm kind of the best case scenario of this because I have my small form factor gaming rig plugged into my TV, 4K TV. I'm playing at a distance. Not only that, I'm playing with a controller. So the input sensitivity is not going to be as widely felt. Also, I like motion blur. Just visually, I usually turn motion blur on for the games that I play. But even then, the original version of frame gen, I still could see some image degradation. This one, for multi-frame gen, I fully expected to come in and be like, okay, I'm going to be able to see these multiple rendered frames, and I did not. The changes that they did, the way they're doing something on the back end, I was super surprised. I think out of this whole launch, that's the thing I've been surprised about the most, is the multi-frame gen. And I mostly ran it in the 4x mode, so 1 real frame and 3 fake frames, whatever. It was not like a super degraded experience.
There's a couple of things they talked about that changed with this new version of frame gen, the multi-frame gen. One is that they're not doing the frame pacing on the CPU. There's actually GPU hardware that does that now.
Okay.
So they're controlling the entire pipeline, which means that they can dump those frames out, those AI-generated frames out at a very predictable rate, and it makes the games feel really smooth.
Yeah.
Which means that you, are getting more frames, so you're less likely to notice individual visual artifacts, and also the visual artifacts were greatly reduced from what I was able to tell by, say, pointing my 240 hertz high-speed camera at the phone and wiggling the mouse back and forth really, really fast.
Yeah, I mean, I feel like if you really, really sit down and look at it, and I'll be curious to see Digital Foundry's breakdown of it as well. I feel like you can see it if you're really looking for it, but I did not in the way that I was playing normally, right? Yeah. I think the other benefit for me was being able to target specific frame rates, right? Because like you mentioned, this is kind of meant for having a base frame rate that is already acceptable. I like 60. I think 50. I was playing around with settings on Indiana Jones, and that is very graphically intensive, and so I was able to get the 2x frame gen feeling in a good spot, even though I had 50 frame base.
And this is when you're playing on a 120 hertz TV, probably?
Yeah. My it's a FreeSync premium panel, okay. So it does have high refresh rate. I did even try to lock down the frame rate to like 30 FPS to see what multi-frame gen would look like off of that, just to see it's not the worst case scenario, but like what does multi-frame gen feel like off of a 30 frame per second video signal, and that I could definitely feel the swimminess. Like it was not great. I really think you should try to hit at least 50 FPS minimum of non-frame gen to be able to get a good experience out of this.
It's the micro stutter and the stuttering is one of those things that I think people don't realize is as big a problem as it is until you see what it's like without it. It's why, like I said, it's why Doom Eternal and Doom 2016 felt so fast. I think this is a big jump. of course, your mileage may vary. It's not something we can really show you in video, unfortunately.
And like I feel like there's already a huge stigma around frame gen. You know, it's like, oh, the fake frames and all that kind of stuff.
Yeah.
So like, you know, we did a poll on the recent episode of the podcast, and a lot of people are like, I don't even want anything to do with it. I think it's pretty crazy that we're able to do with it, and I do think AI in some form or fashion, whether it's upscale or frame generation, is going to be used in gaming, you know, for the future. So
It's a constrained, you know, this is one of those uses of AI that I'm okay with. It's constrained, it's limited, it's very specific, and it's actually improving the experience for me, which at the end of the day is all, you know, that's the thing I care about in this case. Like, is there an actual benefit to this? It feels a lot better, whether it's raster generated or you know, AI generated, not real frames. The game feels smoother.
And I do feel like the jump from the original version of FrameGen to the multi-frame gen here feels like that initial jump from DLSS 1 to DLSS 2 for the upscaling side. Like, and now I'm excited to see, can they make it even better, for sure. Speaking of upscaling, there is some changes for the upscaling stuff. And so, yeah, like, I think we played around this in a couple different games. Like Cyberpunk is kind of one of the ones that graphically you can bring up a toggle and you can change between two different models. Well, please explain these models to me, because I don't fully understand it.
So the old way that DLSS super sampling has worked since, I think, DLSS 2 or maybe even 1. 1 was individually trained on a per game basis, so it only supported a handful of games. I think 2 is when the modern era of DLSS started for all intents and purposes. And it used what's called a convolutional neural network. And the idea is that it could look at a pixel and it could say, oh, the pixels, this color pixel is going to have these other color pixels around it typically, right? It's fairly straightforward, right? So you know, the idea is, it uses this information to increase the resolution of the rendered image. Take a lower resolution rendered image, say a 720p image, and render it at 1080p, right? The idea is, hey, these pixels are similar to the ones around them. We can extrapolate out from there. We make the image bigger, and it looks better than the other traditional methods of upsampling. Now, there were artifacts, right? Occasionally you'd have, it's just like with generative AI. Sometimes you have things like the fingers look weird, or there's a ghost hand, or the hair renders extra hair beside someone. And they built a bunch of different models that kind of accounted for that. But that all happened fundamentally because at the end of the day, all it's doing is looking at the pixels in its basic vicinity. With this DLSS 4, they're beta testing a transformer neural network, a new thing, which is similar to what's used with ChatGPT. And the idea is that it has a more holistic view about everything that's in the scene. So while the convolutional neural network will just want to know what the adjacent pixels look like, the transformer neural network will know that, hey, there's a dog over here, so maybe there's going to be more dog. There's a dog in the top left side of my screen. Maybe there's going to be another dog in the lower right side of the screen, because this is a picture that has dogs in it. And as a result, it can give more accurate, better, clearer, more crisp information because it knows what's going on, not just on the adjacent pixels, but more of the pixels in the scene.
Now, I did not know what to expect from this. Like, I thought maybe this is just kind of like a nerdy math thing on the back end, and but in Cyberpunk specifically, and that's where I messed with it the most, because you can switch between the two, at least in the pre-release copy that we have, and I definitely noticed a difference for the new transformer model. Like the ghosting, the smearing, a lot of those edges that tend to not be clean on upsampled stuff was like much better. Like like very, very impressive.
So the thing that they spoke about specifically at the editor's day is that they switched models. The transformer model is much more computationally expensive. It uses tensor cores, so it's parts of the processor of the GPU that aren't necessarily being used by the raster render sections, but will be used by FrameGen and upsampling and all that kind of stuff. The reason they switched to the transformer is because they seem to have hit the limits of what they could train on the convolutional models, and this is giving them more kind of room to grow.
Well, hey, I mean, it's good, and this will be coming to all RTX GPUs.
Yes,
but
asterisk.
But like you said, though, it is going to take a little bit more computationally intensive. And hey, guess what? 50 series is probably the best suited one for it.
And right now, the only thing that I think we had that we could actually test it in was natively was Cyberpunk. You could force it on in a couple of other games. I think Dragon's Age Veilguard and I don't remember what the last one was.
Rivals.
Marvel Rivals, yeah. So it's a little bit hard to test right now. I'm hoping to see more implementations rolled out shortly.
Yeah, well, and there's definitely more testing to do. We actually do have a benchmark for like the actual performance of multi-frame gen, upscaling, all that kind of stuff. But I know you plan on doing a following up video, just kind of looking at DLSS 4 and kind of digging deeper into all that kind of stuff. So we'll have more information.
Yeah, image comparisons, all that. We're going to zoom in on images, we're going to get crazy.
All that fun stuff. Okay, so the final parts of DLSS to talk about are things that we actually didn't really get to test. It includes Reflex 2, ray reconstruction, mega geometry, really cool stuff they showed off at the Editor's Day, and I did get to see some demos there, but we didn't really get a chance to test any of that.
So we'll talk about ray reconstruction in the DLSS deep dive that's coming soon. Reflex 2 is coming to the finals and Valorant, but it's not available yet for us to test outside of some floor demos at CES. And then the mega geometry stuff is going to be in Alan Wake 2 by the time the cards are available, I believe, is what I've been told. We haven't had a chance to test it yet.
Yeah, so more to come on DLSS. Yeah. Either way, I mean, the package continues to get fleshed out. They keep adding stuff and like making it a full feature, dish of things.
I think of DLSS as a bucket that they throw AI into to make your games faster.
Exactly. And whether you want that bucket or not, I guess that's up to you.
You can opt out of the bucket if you want.
Yeah, we like the bucket around here. All right, now for the fun stuff. We got benchmarks. We got charts. Everyone loves a good chart. Before we get to it, we do need to lay out the test bench configuration. If you want to go look at all the specifications, go read in the description. I list out every piece of the bench. But the main piece we wanted to talk about real quickly is the CPU. Yeah. So we decided to pair the 5090 with a Ryzen 9 7950X 3D.
Yeah, this is the dual CCD part, last generation, unfortunately, because the current generation not available yet.
Not available yet.
We would love to have them, but AMD wasn't interested in sending us early access to CPUs to test NVIDIA video cards. Weird. The point is, it's the best of both worlds, right? It's got the 3D V-cache for games. It's got high clock speeds for productivity stuff. And since we do a mixture of productivity and gaming tests, it seemed like the better choice than using one CPU for productivity stuff and a different CPU for gaming tests.
Yeah. And I mean, even on the gaming, the 7950X3D is still within percentage points of the 9800X3D, which is obviously the best CPU for gaming. And when you're doing these kind of benchmarks, we are trying to alleviate all the bottlenecks that are there to just see the pure results from the GPU itself. But I felt like having this kind of different configuration is going to be beneficial just to kind of see some other productivity tests. Also, I think a lot of people will be testing this GPU with either the 9800X3D or the 14900K. I kind of wanted to see some results from the CPU as well. So, okay, one more thing before we get into the numbers.
Yeah.
Guess what? This thing's fast.
It's stupid fast.
It's stupid fast.
Like the performance gap, the least amount faster it is than the last card is like 13%, which in CPU land people would be doing like there'd be fireworks and everything.
Yeah.
It goes up to like 150, 200% faster depending on the benchmarks and whether you turn frame gen on.
Right, of course, yeah, because that was the thing. Nvidia came out with their initial numbers. Almost all of it was exclusively with multi-frame gen versus normal frame gen. So we wanted to test in a couple different scenarios. We have raster numbers, we have ray tracing numbers, we have upscaling numbers, we have multi-frame gen numbers. So we wanted to test a lot of different ways to just kind of see what to expect from it. But we also didn't have a ton of time in the world, so we kind of had to pick our battles and figure out which games, which engines, which configurations we wanted to see to kind of get at least a little taste of what this card can do. And we compared it specifically against the previous card. So we have the 4090 here. And then even though AMD does not have a comparable card, I did want to include the 7900 XTX. This is a Sapphire Pulse version. And hey, guess what? This GPU is half the price. Or more than half the price actually, and it's going to be at the bottom of all these benchmarks, but I did want to include it because I thought it was important to kind of at least have a little bit of a gauge.
Yeah, you want to know where the other guy is, even if they're not really competing in the same. They might not be swimming in the same pool, but it goes in the same slot.
Yeah. Well, hey, and in some scenarios, it actually was closer than I expected. So first off is raster numbers, and we have Assassin's Creed Valhalla run at 4K with the ultra high preset and no upscaling. This also reports the 1% lows, and I'll tell you, the jump for a $1,000 7900 XTX or $1,000 MSRP launch price, 7900 XTX to a 5090 is actually not as big as I expected, but that's also just because of this specific engine. Definitely favors a little bit more on the AMD side.
Yeah.
So, but still, hey, guess what? Bigger bar better. And much better than the 4090. So yeah. But if we switch over to Call of Duty Black Ops 6,
so this is a currently active live game that people are playing every day. Thousands and thousands of people are playing every day.
Yeah.
It's designed to be performant. They care about frame drop, stuff like that.
And because it was also, like you said earlier, an online shooter where you're probably not going to want to use frame gen, we did not put that on, but we do have an upscale factor of 2, so it was natively running at 1080p, and then upscaling to 4K with the extreme preset. And man, the 5090 is still turning in a huge number. Is it leagues away better than the 4090 or even the 7800 XTX?
It's 12.27% faster than the 4090.
But hey, bigger bar better. That's what we say around here, right? The one thing to note that is a little curious is that the delta between the 1% lows and the averages on the 5090 were actually worse than the 4090. Not by a ton, but still enough that I'd be curious to see why that was.
Typically, I'd wonder if you're CPU bound on this, but when we looked at the actual results, COD actually reports that, and
it's less than 10%.
It didn't indicate that it was CPU bound. You could have a couple, a small percentage of really low frames that's pulling the whole thing down.
Yeah, so
something to look at.
It's curious.
Pre-release cards, often things are weird.
Yeah. Well, let's switch over to Cyberpunk 2077. This was run with 4K Ultra preset, but no ray tracing, no upscaling, and no frame gen. This is just a straight raster performance of this card, and we are still getting on the 5090 almost a 120 frames a second on the averages. This thing chewed through Cyberpunk.
Yeah, this is about a 50% performance difference between the 4090 and the 5090.
That's wild.
And now here's the thing. This is the mode that nobody's going to play, right? Because if you're buying a 5090,
I mean, you could theoretically though. Look at that.
But
at 4K, you're getting almost 120 frames a second.
If you're spending money on a 5090, for the love of God, turn ray tracing on. Okay. It's an impressive difference. The tricky part about all of this with these cards is it's hard to find games that are going to be GPU bound with current CPUs at the resolutions that we have monitors to test on.
Right. Yeah.
So this is your number.
Well, but hey, at least coming out of this whole announcement out of CES, there was some conjecture of like, okay, well, they're only showing frame generation numbers and ray tracing numbers.
That was my concern.
Does that mean the raster performance is not going to have a huge uplift? Well, guess what? This is a huge uplift, at least in Cyberpunk. And hey, we know that Cyberpunk plays well with Nvidia hardware, but I mean, I did not expect to see that kind of raster jump from gen to gen.
I think the thing that's happened with this new card is that we're seeing the bottlenecks shift around, and some games are poised to benefit from that, like Cyberpunk. Some games are seeing less benefit from that, like we did with COD. So
okay, we got a couple more just pure raster benchmarks here. Next up is Shadow of the Tomb Raider at 4K with the highest preset, but no RT and no upscaling. And you know what? The way the numbers play out look kind of identical to the other charts, right? It's not as big as like the Cyberpunk jump, but here we are still seeing a pretty healthy jump in just pure raster performance.
Yeah, and it's worth noting the second bar on this one, the gray bar on this chart, is the 95% average frames. So this is the slowest 95% or the fastest 95%?
The fastest of the GPU specifically. Yeah.
Got it. Okay.
So so a little bit different, but we're just using what it reports. It still is a good indication at least.
Yeah.
And the last pure raster is Tom Clancy's Rainbow Six Siege. This is at 4K with the very high preset, which usually when you select a preset, it will default to a 50% render. But this is not using any sort of upscaling. This is literally just a linear
this is rendering
scaling.
4K worth of frames.
Yeah. So I went in and specifically changed it to 100%. This is not at 1080p. And also this is in the DX11 mode. Which I wanted to see DLX11 performance, just to kind of throw a curveball.
It's nice to make sure.
Yeah, it's nice to make sure that, hey, these new GPUs are not throwing away older renders. And hey, guess what? Bigger bar better.
It's faster.
It's just, I mean, 330 frames on average at 4K. Like, yeah. Do you need more frames than that, actually?
I mean, I have a 360 hertz monitor, so I could use 30 more.
Oh,
if you
okay.
give me 30 more, it'd be good.
Just a couple
well,
more.
29.
Yeah.
I lock it at 359 just to, get that frame, get that judder down.
Okay. Yeah. Well, I guess I'll have to try on the next one.
Yeah. Do better, Ubisoft.
So next up, we have a grouping of ray tracing titles. So a lot of these will be using upscaling. And maybe even a little bit of frame generation, but we kind of wanted to see the actual ray tracing performance capabilities of this new card.
Separate from the frame gen.
Yeah. So the first up is Black Myth Wukong. This is a Unreal Engine 5 title, and this only reports 5% lows, so that's what that second bar is. And yes, we need to address that AMD card. What the hell's going on there?
Yeah, so it's a full path tracing implementation on this game when you turn on ray tracing.
Yep.
Which AMD is not hanging with full path tracing on the RDNA 3 cards.
And also in the game, it literally is called Nvidia ray tracing when you're selecting it. I did use the cinematic preset, so this is the highest thing. RT very high preset, which is the highest thing. We did upscale it ×2, so it's natively rendering at 1080p, but frame generation was off for this one. So we are using upscaling, and man, this benchmark is definitely a hard one to chew through, but it did get over an average of 60 frames a second. So
yeah, does this game doesn't support the new frame gen, but it's only the 2x frame gen from the last gen.
Just the 2x, but I didn't turn it on for this one just to kind of see like for like. So
with the last gen ATI hardware, it's kind of hard to compare frame gen. So this is I thought this was a really nice uplift. This is like 25%. It's impressive.
Now let's go back to Cyberpunk.
31%.
Oh, 31%. Let's go back to Cyberpunk. So I ran 4K with the Ultra preset, but RT Overdrive preset. So that one turned on the full path tracing implementation in the hardware. Frame generation was off for this one. We've got a frame generation one later. And this upscale was 1.7 times. So this is the balanced preset.
Okay.
So this was rendering at 1200p, 1240p.
It's not a real resolution. It's in between 1080p and 1440p.
Exactly, yeah. So this was the best kind of upscaling to get about a smooth 60 on a 4090, but we are getting an uplift on the 5090 as well. And yeah, unfortunately with that full path tracing implementation, AMD just cannot keep up at this level. But hey, a good uplift in specifically ray tracing.
Yeah, it's interesting to me to see that we're seeing. I mean, they did some optimization on the ray tracing engine on the 5090, and I think that's what we're seeing here is that their ray tracing hardware is more effective per clock than previous generations. So
yeah, I like it. Next up, we have F1 2024. So this does have a very light implementation of ray tracing. This is at 4K with the ultra high preset. No upscaling, no frame gen, but it is using the highest ray tracing possible in that ultra high preset. And this was a big uplift. This gets you well over 120 frames per second average on that 5090.
Yeah, I was a little bit surprised by this because this game typically when we run it, we use it in a lot of different places for different things, and we don't typically run it at 4K at high resolution because we often use it as like a CPU benchmark.
Yeah.
It's interesting that I didn't expect to see much difference between the two cards on this. So again, probably a testament to both the raster the increased memory bandwidth and the increased ray tracing performance.
And this is probably the one that I would have expected to see a little bit more of a CPU bottleneck, but we're still seeing like the same kind of uplift gen from gen. The very last RT thing that we have here is Returnal. This is a 4K with the Epic preset, RT on, but no upscaling. So this is just pure 4K with all the bells and whistles. In this game, you definitely want to have really high frame rates, and we're not quite pushing 120 frames a second on the 5090. But once again, that is a nice uplift over the 4090, not only in the averages, but even in the minimum frame.
And this is a good example of another place where I probably wouldn't. This isn't probably how I would play the game if I was playing the game to play the game and not to test.
Yeah.
I would run this with the quality upscale on and take a few more frames in exchange for a little bit of image quality. But yeah, this is a nice uplift gen to gen.
Yeah.
Okay, so now we're into what I like to think of as the cyberpunk section of this little voyage. we're going to look at different characteristics of the game with different DLSS and frame gen on at different levels. And this was a place that I think you were kind of surprised by how this worked in practice.
Yeah, and just so you know, for this launch, there were a handful of games that had multi-frame gen capabilities inside of them. Cyberpunk was the only one that you could actually run a built-in benchmark, and we like to rely on built-in benchmarks around here for the repeatability. There were a couple games that you could actually force it on in the driver level. I had a little wonkiness here and there with Dragon Age. That's the one that I tried it on. So, you know, I definitely messed around with it in a bunch of different ways, but this is the only one that I actually like benchmarked. And I ran it 3 different ways.
Okay.
So we're gonna go back and show some of the slides that we showed before, but I think this is to kind of show the uplift that you're gonna get by turning on some of these features. So this first chart is going back to the 4K Ultra preset with no RT, no upscaling, no frame gen. So you know what kind of performance you're going to get out of that.
Yeah.
Next up, we turn on RT Overdrive, which is the full path tracing. Frame gen is still off, but the upscaling is at 1.7x. And you know, you definitely see a hit in overall performance, but what you're getting from it visually is the idea is that you're supposed to get something visually from it.
Reflections, shadows,
everything.
The lights, the thing. When your jacket has a gap between your jacket and your shirt, it shadows the shirt underneath the jacket. Like stuff that is expensive or impossible in a traditional raster environment is just table stakes with the ray tracing.
Yeah, so some people might say, hey, you know what? I don't want to take a hit to the overall frame rate just to turn on ray tracing. Hey, totally get it. You do you. You don't have to.
Yeah.
But I do. I like to turn it on. And so the idea is that, hey, maybe frame gen is another thing to claw back performance, kind of like upscaling, right? And so for this one, I ran it a couple different ways. So there's a 4th option here because I have the 5090 running at the multi-frame generation and the old vanilla frame generation, so the 2 times. I will say that the non-multi-frame generation numbers were all tested with the release version of Cyberpunk 2077, where the multi-frame generation one at the top was tested with a pre-release version of Cyberpunk. So a little different, but it should be theoretically similar.
Comparable, but a little, yeah. So, okay, so there's 2 things that are interesting here to me. One is that you're not getting a straight multiplier in terms of the frame rate boost from turning on the frame generation and then multi-frame generation.
Yeah, I was confused by that.
It's kind of to be expected because sometimes the frames come in late and the pacing gets off, so they'll discard frames to catch up to get in the right place so that the rasterized frames are where they need to be in order to keep everything running nice and buttery smooth.
Okay.
But you know, they're fake frames anyway, so who cares, right?
Oh, God. Yeah,
I'm kidding. It's interesting here, the uplift. You're going essentially from 78 frames a second with the Founders Edition and the path tracing, which is a playable frame rate, to something that's actually going to make your expensive 244 hertz monitor look really nice. With the multi-frame generation, which I think is their goal here.
Yeah, and I will say that even though this test bench has the 7950 X3D and Nvidia provided numbers, sanity check numbers with the 9800 X3D, this was only a handful of frames off. So we're within there. So you saw Nvidia's numbers, and then these are kind of the numbers for testing it in multiple different ways. I think at the end of the day, these tools, whether you decide to use them or not, it's nice to have them there because that's the glory of the PC, is that you can kind of like configure it however you want. Do you want to mod it? Do you want to run it at 4K at 1080p? Do you want to run it with frame generation? Do you want to run it with full path tracing? That's the glory of the PC, is that you get to have it the way you want to. And how that shows up, at least in Cyberpunk, and a handful of the other games they had at launch, was that you actually go into the game and you get to pick the level of frame generation. Now, Cyberpunk did require a relaunch of the game to enable frame generation, even the original one. But once you're in there, you can pick 2, 3, or 4 times depending on what you want. You can also, at least in this pre-release version, you could pick the transformer model depending on which one you wanted. And hey, listen, some people just want that raster number. Guess what? You got it. And some people maybe just want to use upscaling. They don't like frame gen. Well, we got those numbers. And then some people might be curious to see what frame gen can get you, and we got you those numbers as well.
To me, the interesting thing is, right now we have, I think, 2 games that are accessible to us that you can turn on the new transformer model DLSS and the transformer model FrameGen. In the control panel, that's I think Veilguard and Marvel Rivals. I want to spend more time with the new model DLSS because so far what I've seen out of the early examples, especially with Cyberpunk, have been really remarkable.
And it's still early days, right? Yeah, I mean, this is just one game. And like I said, they only had a handful of games for us to test at launch. So I'm curious to see the implementation in more games and even how different developers implement it as well. I will say, like, when you're trying to force some of the stuff on in the driver level, which is kind of interesting, this is not... You can't do this for every game.
Yeah,
like
they have it disabled for for most games.
It's grayed out, so it's not like you can all of a sudden unlock all of your games to have multi-frame gen at the driver level. It still needs to be implemented.
Or it has to be enabled, and this happens through the Nvidia app, the replacement for GeForce Experience. It's kind of the melding of the GeForce Experience in the old Nvidia control panel.
Yeah,
I like I said, none of the performance numbers matter if the image quality and the feel isn't there. Yeah. And the stuff that we saw felt remarkable.
Yeah, very, very, very interesting indeed. Also very interesting is production numbers. So that's all the gaming benchmarks that we have. Now let's get into some of the content creation production numbers. I definitely want to get more into this as well because that's kind of like what I love to dig around into. But we got a couple different things.
Yeah.
And one of them is something that's new that we're trying is AI text generation. So Procyon has a built-in benchmark for AI text generation, and what it's doing is measuring the token, the time to token and generation kind of stuff. And so
across multiple models.
Across multiple models, we got 4 in there, and then it spits out a nice little score. So, it's funny. This is kind of the same way the charts were lining up for the gaming benchmarks.
It's weird that it's performing faster than everything else at exactly the same percentages.
Exactly, but the 7900 XTX is definitely falling behind a little bit more in the AI text generation stuff. I say it's early days for benchmarking AI because going back for years and years, Gordon and I would talk about AI, and we knew it was coming out, but how do we benchmark it? How do we find something that's reliable for people to understand or even grasp? And I still don't feel like there's an AI silver bullet out there that everyone should be using this AI feature, but a lot of people do use text generation, so I thought it was interesting to kind of throw in.
Well, a lot of the challenges that a lot of the generative AI stuff especially isn't deterministic, meaning you can run it 5 times and the results are different each of the 5 times.
Yep.
You can configure them to be deterministic, but often, for example, like stable diffusion in its default state is not a deterministic. If you type, draw me a picture of a puppy, it's going to give you 5 different puppies when you run it 5 different times. And that makes for a dangerous benchmark, not necessarily a bad benchmark,
yep.
but it's the Procyon benchmark is a nice first step for dipping our toes.
And hey,
into this.
I mean, UL has a long history of making benchmarks, so that's why we run to rely on them. If you have any ideas for benchmarks, that you'd like to see run for AI workloads, maybe put them down in the comments. I'd be very, very curious to see that. But something near and dear to my heart is Adobe apps, for better or worse. It's near and dear to my heart.
This is a shocker.
Yeah, Photoshop is up first, and you would think, oh, you don't need a 5090 for Photoshop, and guess what? You don't.
No.
Yeah, it is not specifically GPU bound, but I did want to kind of see if there was any differences in NVIDIA versus AMD.
Is this bigger, more, better, just to be clear?
This is the one chart that we have where the AMD GPU produced the bigger number better. So, yeah, good job, AMD. Yeah. In Photoshop, if you're really trying to get the most out of your Photoshop, skip the 5090. You can maybe save $1,000+ and just go with the AMD version.
I don't know that you need a $1,000 card for Photoshop, but I could be wrong.
Hey, you know what? Some people like the best.
Yeah.
Some people like the best. Some place where it is a lot more GPU intensive is Premiere Pro. So the 5090 has a nice uplift over here. It does have 3 encoders, but I actually don't think we're seeing the uplift just by having that 3rd encoder over the 4090. I mean, you're getting an uplift for sure, but this is, I looked at the subscores and it's mostly just in the same places.
The video encode.
Yeah. So it's a nice uplift, but also, I mean, if you have a 4090, guess what? Now the 4090 is the 2nd fastest consumer card in the world.
Yeah, you're probably fine.
Yeah, for video editing. I mean, unless you want to, I guess the other thing that this can afford is sticking multiple these
Yeah, you
cards.
should put two 5090s in your machine. Then you can have like 6, 7 monitors attached.
Which Premiere Pro can't take advantage of that, but DaVinci Resolve does take advantage of multi-GPUs. So I didn't get a chance to test that, but that's something maybe I'll test in the future if I have some time, because I'm very curious to see what those results would be. So that's it for all the gaming and production benchmarks. I wish we had more time, of course, but there will be more follow-ups to get into those numbers. But the last thing that we have charts for is power draw.
Yeah.
And I will say the way that we test power draw here is by going with the full system rather than getting into the nitty-gritty details of the GPU itself. Steve will, I'm sure, have some great deep dives into the power draw of that. But as Gordon would always like to say, you're not just paying your power bill for the GPU and the CPU separately, it's all together. So we kind of wanted to see how that works.
Well, and nothing else is changing in these systems except for the GPU and the drivers associated. So.
Exactly, yeah. So we tested in 2 different ways. First up is the idle power draw, and I just let this sit here at a Windows screen for 5-10 minutes and just got the whole thing. There are a couple bumps in there because probably some task in Windows was going on in the background, so ignore that. But we are seeing at idle the 7900 XTX is actually turning in the best score.
Yeah.
But I mean, we're also not talking about a ton of different wattage here, and the 5090 is actually a little bit better than the 4090 at idle.
Yeah, the averages when you take all the samples were 140 watts for the 5090, 146.5 watts for the 4090, and about 128 and 6/10 watts for the 7900 XTX. And the perf difference 5090 to 4090. The 5090 is about a 4.5% power savings at idle, which is nice.
Oh yeah, you get 4% back off your power bill.
I mean, it's look here
at idle.
Look, you got to spend more to save more. That's what I say here.
Exactly.
That's what we always say at PCWorld.
Yeah,
spend more to save more.
Something like that. Speaking of spending more, now let's get to a full gaming load. This was under Cyberpunk 2077 4K, just fully stressed out the system to try to crank as much wattage as we can out of here, and boom.
Hey, mission accomplished.
Wow.
Good job. 700 watt peaks on the 5090. That is a beefy lad.
Hey, yeah. I mean, the story between the 4090 and the 7900 XTX was known already, but man, we cranked up that 5090 to over 700 watts. That is an increase over the 4090 of.
Well, the average is 28.5%, but the peaks are going to be higher because it's like the peak of a 510 watts for the 4090. To the 702 or 3 watts of the 5090, it's a lot.
Well, and actually, the math did check out between between the actual TGP of the 4090 and the TGP of the 5090. The jump is about the same as we're seeing here.
Yeah.
And so guess what? You could use a lot more power to do it. You do get bigger numbers out of it.
You do get bigger numbers.
Yeah, so I mean, at the end of the day, I guess that's the thing. Let's recap, right? So it's smaller than the 4090.
Yeah.
It is quiet.
It's about the same, maybe a little tiny bit indistinguishably louder, I would say.
Depending. It is a little hotter.
Yeah.
It is a little hotter. It does have new DLSS features.
That's true.
In raster, we're seeing jumps anywhere from 10% to 50% in performance.
It's worth mentioning the only DLSS feature that's limited to this card is the multi-frame generation.
True.
Everything else is going to be on the older cards with the driver updates.
Yeah. In RT, we're seeing a nice generational uplift there.
Yeah.
Obviously, you have the multi-frame generation available to you on the 5090, and you didn't have it on the 4090, at least for now. Maybe that'll change in the future. But to do it, well, and you are paying more for the benefit of getting all this, and at the back end, you are definitely getting a lot more juice pumped out of this.
Well, so for me, when I look at this, the numbers that this is churning out with games that are available today and the types of games we expect to see in the future, because at the end of the day, with the exception of a handful of games like Alan Wake and Cyberpunk that are, use vendor-specific features, the games we see are defined by the consoles that are out in the world today, right?
True.
And like the only reason you need this card is if you have a 4K 244 plus hertz display, or you're competitive in esports, or you're an AI researcher, or you like to have the fastest card that you can buy because it's cool.
I would say it falls a little bit more on that other side. Like for gaming, like come on, this is overkill. Actually, for multi-frame generation on a 5090, it's overkill too. You kind of don't need it for the most part. Like, it's nice to have it there, but I'm more curious to see how multi-frame gen works on the lower end of the stack, like a 5070, because there you probably are having to make hard decisions about getting the performance you want. On a 5090, you're almost about to brute force your way through everything.
It's funny because coming out of the test results with this, the thing I wonder about more than anything is if the 5070 has the raster juice to get enough base frames at 1440p that we can turn the gas on with multi-frame gen and actually see good looking multi-frame gen. Because the difference between the low frame rate multi-frame gen and the high frame rate multi-frame gen is pretty remarkable.
Yeah. And so hey, listen, Nvidia owns the top end of the stack.
Yeah.
Because even though we're saying the 5090 is the fastest, consumer card out there, number 2 is the 4090. That doesn't change. So like it's still they still command the top end of the market. And even though like the 4090 is going away, it's not like they're going to continue to sell them. They're saying, hey, you know what? If you want the best of the best, and you're willing to pay, and you're not worried about power draw, then here you go, have it. Go hog wild, do your AI research, all that kind of stuff. I don't fully think this is like a gaming GPU. It feels weird calling it a gaming GPU because it's just so overkill.
I think that's the big question I have is the 4090 going to be the number 2 once we have 5080 benchmarks in? Right? Is the 5080 going to surpass the 4090? There's memory configuration stuff, but really we're not seeing games that are saturating the memory configuration on a 4090, much less a 32 gig 5090. Right. So, it's a wild time for high-end GPUs in a lot of ways. And I think, we're not going to know where this falls. I want to know what the AIB cards look like, whether they're outperforming this Founders Edition, because usually more slots, bigger coolers means faster cards. And, if this is the slow one,
this could be the slow one.
This could be the slow one.
Yeah.
We don't know yet.
We don't know. Yeah. I'm very curious to see that for sure. I mean, I will say you do get some benefits from AIB, in terms of like availability. Usually it's way more widely available than the Founders Edition. You do get different designs, so maybe you don't like the look of this one, or maybe you don't care that it's too
maybe
slow.
You want a water block to go into your loop, or
exactly. Yeah. So there's that, and then we'll have to see: is there a performance benefit, a thermal benefit, a noise benefit, anything like that? I am curious to see that. But yeah, going down the rest of the stack, that is the other question. And yeah, 5080 is the next one up. The 5070 Ti and the 5070 is going to follow a little bit later. So yeah, more to come. But thank you for sitting through this and chatting.
And these are out on the 30th of January. If you're watching this
true.
when we post embargo.
And $2,000 for the Founders Edition if you can find it. We still don't have final pricing as of right now for the AIB card. So yeah, that's it for this video. I want to thank Will for helping me test. Brad definitely did help me figure out some of the configuration stuff as well. And then Will, you definitely helped me get some insights into what these benchmark numbers mean, because I don't always know what they mean.
Well, and we're gonna have more to come. Like the thing that's interesting, I think this lives and dies on DLSS 4. This whole family of cards does, because the way they're positioning them is, hey, multi-frame generation matters. Of course, the internet is fake frames, real frames, blah, 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 blah. And it's like Alex said a little while ago from off camera, at the end of the day, aren't all the frames fake frames?